In this video, we're going to calculate the volume of revolution and we're going to use the washer method. And you'll see once we set up the problem why we need a washer method. Very quickly, a washer essentially looks something like this. It's a thin cylindrical disc, but with a hole in it. Okay, so okay, and the area of cross section of a washer, let's say that the inner radius is say R1 and then the outer radius is R2, then the area of cross section of the washer is equal to pi times R2 square minus pi times R1 square. Okay, so area of the large circle minus the area of the hole. Okay, so let's take a situation and let's figure this out. So let's first draw our region. So let's take our curves, say y equal to x, okay, and then y equal to x squared. And this time, what we're going to do is we're going to take this region R, okay, and we're going to spin it about the x-axis. Okay, now just like the previous videos where we had a solid region R that we revolved around the y about each of the axes. Okay, what we'll do is we'll draw the image, okay, or the reflection of this about the x-axis, and then we'll look at our solid. So if you look at what these solids will look like, okay, since we are revolving this would be the outer one, okay, and then we would have the hole that comes out, and then this would be the some amount of thickness. So we ask the question now, the slices, if you look at the slices, these slices are perpendicular with the x-axis. Okay, so we want our slice to be a function of x, but in this case, since we have a washer, we need to make sure that we have our correct radii. Okay, so the inner radii is the function y1, it's equal to x squared. The outer radii is the function y2 is equal to x. So we can now find the area of our cross section, A, as a function of x, is going to be equal to pi times y2 square minus pi times y1 square. Okay, now we can replace y2 and y1 with their corresponding x values. So pi times y2 square is simply x square, and then y1 square is x square the whole square. Okay, so that gives us a as a function of a as a function of x, which is pi x squared minus pi times x to the fourth. We have our area of cross section. Now we can find our volume. Volume is once again 0 to 1 because that's where they intersect. A of x dx, which is integral 0 to 1 pi x squared minus pi x to the fourth dx, and this will be equal to pi times x cubed over 3 minus pi times x to the 4 over 4. Everything goes from 0 to 1. And we put our appropriate limits, we end up with pi over 3 minus pi over 4, which is pi divided by 12. So this is the volume of revolution about the x-axis. Now if we were to revolve the same shape about the y-axis, let's see how we go about doing that. So we have our shape once again here. Okay, and this time again I will draw my reflection perpendicular, sorry, drawn reflected about the y-axis, and let us draw our washers. So we get the outer circle, get rid of the hole. Okay, now this time our radii, inner radii is some x1 and the outer radii is some x2. Okay, or I mean if I were to draw it here all the way, it would be some amount x2. Okay, so our cross-sectional area this time is going to be a function of y. It is going to be equal to pi times x2 square minus pi times x1 square. Now what is x2? x2 is the outer function, which was square root of y, and the inner function is simply y. So we can just leave it like that, and we're going to square both these guys, and we end up with pi times y minus pi times y squared. Alright, we have the area of cross section. We can find the volume. The volume is going to be equal to integral 0 to 1, the area of the cross section, and multiplied by dy. And this becomes 0 to 1 pi y minus pi times y squared dy, which becomes pi y squared over 2 minus pi y cubed divided by 3, 0 to 1, which is equal to pi over 2 minus pi divided by 3, and which becomes pi over 6. So this is the volume of the solid of revolution about the y-axis. So if you have functions, of this kind, draw the function. If there is a hole, then figure out the hole, and then the rest of the problem should be pretty straightforward. All right, I hope that helps.